Welcome everyone. I'd like to share something I've been working on, Codexity. It's built around a simple idea, code worry-free. As many of us know, coding can sometimes be exhausting because of the repetitive nature of some tasks or because of the debugging part, and this picture might resonate with a few of you. Thankfully, coding assistants such as large language model can greatly simplify our task. However, one significant challenge we often face is the unintentional introduction of security flaws in the code they produce. This is where Codexity comes into play. Our tool ensures that any code generated is guarded against security flaws. In essence, Codexity aims to make sure that you can code without any worry. At the heart of Codexity, we have developed two distinct approaches to tackle this challenge. By offering dual solutions, we aim to provide flexibility and adaptability to different user preferences. Let's delve into these two solutions. Our first approach is termed iteration repair. Initially, the user provides a code snippet as a prompt to the large language model. The model then completes the code, and we don't know at this stage whether the code has security flaws. To determine this, we analyze the produced code using various static analysis security testing tools, and if a security flaw is identified, we don't directly share it with the user. Instead, we refine the prompt based on the tool's feedback and fed both the vulnerable code and the refined prompt back to the model. This process is repeated until no security flaws are found, at which point the code is shared with the user. Moving on, our second approach is called pre-shot repair. Initially, a prompt is sent to a compact large language model which can be executed locally on a typical computer. The model then generates a code sample, then a suite of SAST tools assesses this code. Should any security flaws arise, we engage in prompt refinement based on the feedback received. Consequently, our primary large language model receives this fine-tuned guidance and is asked to produce code devoid of the vulnerabilities that the smaller large language model has generated. The idea of this strategy is that this local model can mimic and expose potential flaws, thereby reducing dependency on frequent API calls to the primary model. Let's see how Codexity works. To make our tool more user-friendly, we developed a VS Code extension that acts as a primary interface, allowing users to easily complete code in their project. You will see that it's pretty intuitive. Let's say we want to complete this code using large language model. Let's try first using GitHub Copilot. So we are using the chat functionality and we ask GitHub Copilot to complete this code. So we take the first answer. However, as you can see, the input size of the user is not checked, whereas W has a limited size, and this can lead to an overflow. Let's try with Codexity and with the iteration repair. The code is being generated using ChatGPT. So the green line is related to CPP check. The next line is to infer, and infer has not detected any vulnerability, whereas CPP check has found a potential overflow. We are now at our third iteration. And as you can see, the input size is limited to 49, preventing the overflow. Now let's try it with the pre-shot repair. So we highlight the code. So we are using CPU because I'm on my MacBook. We are using Santa Coda as a model. Santa Coda has generated a potential overflow that was detected by CPP check. And here, as you can see, the input size is limited, preventing the overflow. This concludes the end of our presentation on Codexity. Thank you for watching. Our tool is available on our GitHub page as an open source tool. Please feel free to visit it.